Okay, welcome back. Hello, BC Calculus. So today we are going to talk about slope fields. We're starting Unit 5. Unit 5 is pretty short. And slope fields are just a way to visually represent the general solution of a function. So I'm just going to kind of draw one. You'll see it in action here. So we're asked to sketch the slope field for dy over dx equals 3x minus 2 using the table below. So we're going to put in values for x, we're going to get dy dx, and we're going to draw this slope field. So if x is equal to negative 2, then dy over dx is going to be negative 6 minus 2, negative 8. If it's negative 1, we're going to have negative 5. 0 will be negative 2. 1 will be 1. And 2 will be 4. Okay, so we've got those values. And then what we need to do is kind of actually just draw the slope here. So when x is negative 2, our slope is negative 8, which is going to be, kind of steep. So it'll be something like this, right? Not very accurate there. And when it's negative 1, it's going to be a little less steep, negative 5. And these are just rough approximations. When it's 0, it's negative 2, so even less steep. When it's 1, it's 1, okay? And when it's 2, it's 4, so it's steep again. So you can see that this is really, not the most accurate, precise thing, but this is a slope field. This is the general solution, kind of gives you the general graph here of the slope. So we can actually also find that solution. So we have dy, I'll just write all this out, and this is going to be more in the next video, but I'll explain it here as well. Dy over dx is equal to 3x minus 2. If we want to solve what the solution is, we're going to rewrite this as dy equals 3x minus 2 dx. And now because we have y's together, x's together, we can integrate both sides. So we're going to get y equals 3 halves x squared minus 2x plus c. And this function is this slope field right here. Okay, so let's kind of walk through this a little more slowly, go step by step here. Let's consider the equation dy over dx is equal to negative xy. Well, first we're asked to compute dy over dx at each set of points and then answer these following questions. So when xy is 1, 1, dy over dx is going to be negative 1 over 1. That's going to be negative 1. Negative 1, we're going to have positive 1. Negative 1, negative 1, we're going to have negative 1. And 1, negative 1, we're going to have 1. So we can see that dy dx is positive in quadrants. Well, it looks like here we're going to be in quadrants 2 and 4, right? And it will be negative in quadrants 1 and 3. Okay? So that, and remember our dy dx is our slope, that's our derivative. So then we're asked to compute dy dx at these sets of points. So at 1, 0, well, that's going to be undefined. And at 2, 0, that's going to be undefined. At negative 1, 0, that'll be undefined. And at negative 2, 0, that'll be undefined. Great. So here now we're asked to write an equation that would describe the slope as undefined. Well, it's undefined when y is equal to 0. And the slope is 0 when x is equal to 0, right? Okay, let's expand on this a little bit more. Here we're asked to consider the values. And can you still see the, yeah, okay. Here we're asked to consider the values of 1, 1. Well, we actually already did that. It's negative 1. This is our dy dx. Forgot to write that down. At 2, 2, we're going to have negative 1. At negative 1, we'll have negative 1. And at negative 2, we'll have negative 1. So what equation is going to express dy dx equals negative 1? Well, in that case, y will be equal to x. And what about when dy dx equals a positive 1? Well, that's going to happen when y equals negative x. Okay? So we can actually use our grid to sketch this slope field. So remember, our slope was 0 when x was 0. So those are always the easiest to draw for me. So I draw these first. Nice and easy. And our slope is undefined when y equals 0. Well, it's not really happening. So I'll just kind of keep, you can fast forward here, but I'm just going to kind of draw through this, right? So so boring. Now these slopes kind of line up with these little dashes line up with the slope. Okay, stop unpausing now. So we've sketched this slope field here, and you can kind of see what we've got going. And we want to actually draw the particular solution that passes through the point 0, 2. So at the point 0, 2, we've got this right here. We can draw that particular solution. And to do that, we're just going to like basically kind of draw, trace, and I didn't do this very well, but trace what is happening at that slope. And you can see mine is really poor because actually, first of all, I drew it at 1, so it should be more like this. There we go. That's better. That's better. The particular solution, which should be the bigger circle there, it's going to be too hard to erase, is, maybe I should do it in red. Anyway, you understand. So that bigger circle, that's our particular solution. So what's the equation for this solution curve? Okay, we can actually find that. And I'm going to do this. You can see here we've got a circle. So it's going to be an x squared plus a y squared equals r squared. And in this case, I mean, we could just write it quickly. X squared plus y squared equals our r is 2, so this is going to be 4. But we can also solve this algebraically. So dy over dx is equal to negative x over y. I'm going to multiply here. So this is going to be, I'll have y dy equals negative x dx. Then I can integrate both sides. So I have 1/2 y squared equals a negative 1/2 x squared, and plus c. You only have to put the plus c on one side because that's just not really necessary. So if I multiply everything by 2, I get y squared equals negative x squared plus c. Again, c times 2 is still just c. That's a constant. So now I have x squared plus y squared equals c. Oops, c. And if we're doing this at the point 0, 2, right? So then I'm going to have 0 squared plus 2 squared equals c, so 4 is equal to c. So then I end up with this right here, x squared plus y squared equals 4. Just exactly what we had earlier that we got from the graph. Okay, hopefully that makes sense. Any questions, comments, leave them in the underneath the video, and I will see you in class. Bye!